When presented with a frequency table, so a table that will give you some kind of class width on the left, so some range of values that something is falling between, and then next to it a frequency column, so how often that thing occurs, there's a few different things that we could do with this information. We could try to plot it as a scatter diagram, or we could try to find a mean, or we could alternatively try to draw on some axes, and yet in a way that doesn't have frequency as the y-axis. Instead, we might wish for the frequency to be the area of a bar that is drawn. So the bigger the bar in general, the bigger the frequency. In that event, though, you would need something else for the y-axis. This you could call frequency density. For this, we have a topic called histograms, and as part of this, we will also just be discussing the concept of interpolation as we go forward. To start off with, if we were to work out some value for frequency density here for when we start plotting this bar graph, we need a formula. We can say that frequency density is going to equal the frequency divided by the class width, which also makes sense because if the class width is going to be the x-axis and the frequency density is now going to be our y-axis, timesing them together would give us the area, and we're looking for the area to be that frequency, and that is how this formula would rearrange. With that in mind, we'll be taking this frequency value and dividing by the difference in these numbers. Or at least we would be doing specifically the difference in those numbers if this was continuous. That is to say that if this was like 0 is less than or equal to x is less than 2, and then down here this was 2 is less than or equal to x is less than 6, and so forth, i.e. these numbers were the same at the end of one group and the beginning of the next, and you just had inequality signs to indicate which one that value specifically belonged to, but there's no gap basically between each of the groups. Here though, if we're just going up to 2 here, and yet starting this next group at 3, we have all the decimals between 2 and 3 being ignored. So, when we determine the class width, what we're going to do is we're actually going to imagine that this is going up to the halfway point. That rather than just stopping at 2 and starting at 3, each one is going up to that midpoint of 2.5. You can't go below 0 here, so we're just going to leave the 0 as is, but then this would go up to 6.5, this would go down to 6.5, and this would go up to 14.5. So 0.5 above and below, depending on which end of the group it is. Now, when we get our frequency density, so taking the first row, our frequency of 10, and divide that by the class width, 0 to 2.5 would just be 2.5. Therefore, your frequency density here is going to be 4. Next, this frequency is 8, and the difference between 2.5 and 6.5 is going to be 4. Therefore, your frequency density is 2. And then here, frequency of 28 divided by, and the difference between 6.5 and 14.5 is 8. So here, you would find that being 3.5. Now that we have our class widths and our frequency density, we can draw up some axes. So the highest frequency density that we have is 4, so we have to at the very least get up to there. So let's say we go up in halves because we are going to have a 0.5. So 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4. And you can go up a bit further if you so wish. And as for this x-axis here for the class width, we'll need to go up to, I'd say, 15 probably. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There we go, and maybe just label every other one. So the 2, 4, 6, 8, 10, 12, 14, 15 at the end, or you could have gone up in 3s or so forth. Now that we have this, we'll just draw on our bars. So between 0 and 2.5, we have a bar that goes up to a height of 4. So 2.5 is going to be about here on ours. Obviously with yours, you'll probably actually have pre-drawn axes, even if you just have to label the numbers. And also you can use a ruler to make sure yours is a straight line. But either way, we'll end up with our first bar being like this. The second, between this 2.5 and 6.5, needs to go up to a height of 2. So we already have this line here at the 2.5, 6.5. It's going to be about here, and that will come off here. And then lastly, from that 6.5 all the way up to the 14.5, we are going to have up till 3.5. So from 4.5 up to here, it's going to rise about there. This is going to come up here, and then you level it off there. Okay, and that's what your histogram would look like. If we had started with the histogram and you wanted to work out a certain area, or no, a certain frequency, you would look to the area. For instance, if we wanted, okay, how many people were above 12? Well, you would find 12, and then you'd work out just what this area here is. So above the 12, and then with that frequency, so this will be 3.5 for the height times a width of 2.5. Alternatively, we could say, well, how many are below 5? So we'd find 5 here. Now this area is made up of parts of two different bars. You can say that the left-hand bar we already know has an area of 10, but then you'd have to add on to it this 2.5 to get you up to 5 times by 2. So another 5 actually, making 15 in total, less than 5. If we wanted a probability, it would then be that number out of the total, which you could then do by working out either all the areas added together, or if you did already have a table, you could just add up the frequencies here. So in this case, a probability of being less than 5 would be 15 out of 46. Once we have this, a further thing we can do is interpolation in order to find out some figures regarding the data, so the median and the quartiles, words you may recognise if you have done box plots already. So the median is the value that is directly in the middle if you were to arrange things from smallest to largest. And then the quartiles, the lower quartile is the value that's a quarter of the way through the data, and the upper quartile is 3/4 of the way through the data. Here, because we don't know actually what the data points are, we just know that they lie somewhere within each of these ranges, we can only create estimates for the median and the quartiles. And to do so, we're going to make the assumption that the data is going to be evenly spread throughout the group. So here, if there's 10 pieces of data in the range of 0 to 2.5, then there'll be a piece of data every 0.25, as it were. The formula we can use for this, once we've identified which group or which range, which class width, we can say that this is going to be the lower boundary of a given group, or of the class width, add how far into the group, and hopefully once we start using those numbers it'll be clear what I mean by that, divided by the frequency, and then that fraction is being times by the class width. So in this case, we already said that there are 46 terms in total, half of which would be 23. So the median is the 23rd term. Going through the frequencies, okay, we've got 10 from the first group. If we then add on to the second group, we've got to 18. That's not at 23 yet, so the 23rd term is going to lie somewhere in this third range here. The lower boundary of this class width is the 6.5. So we'll put that first, and then we'll add on to it. If we're currently at 18 and we're trying to get to the 23rd term, how far into this next group do we need to go? We'd need to go 5. 18 at 5 would get us to the 23. And what is the total frequency? That's 28. And then this fraction is going to be times by the class width here. That's the class width of 8. So you would then just put this into your calculator, and it would get you, if say to 2 decimal places, 7.93 as yet being your middle value if we're assuming that they're evenly spread, and then they're also put from smallest to largest. If we wanted the quartiles as well, so we want the lower quartile, that would be a quarter of the way through. Well, a quarter is going to be half of the 23, so that's going to get us 11.5. That is going to lie in the second group here. So the lower boundary of that is 2.5. And then right now we're currently at 10. So to get to 11.5, we're going to need to add 1.5. And that's over the class width, the frequency of 8, and you'll times that by the class width of 4. That in turn is going to get you 3.25. Yeah, that's for your lower quartile. As for the upper, well, if you would now add the 11.5 to the 23, so a quarter add a half is going to get us a 3/4 mark, or you can just do 3 times 11.5. We're going to be looking for the 34.5 mark. Once again, that is going to get us into the third row here, so our lower boundary once more is a 6.5. Here, because we're at 18, and you're now looking to get up to 34.5, that's going to be 16.5 on the top here, still over 28, and still times 8. So to 2 decimal places, that would get you 11.21 for your upper quartile. If from this you also wanted the interquartile range, which is your upper quartile minus your lower quartile, measuring the spread of the data on average, you'd be then doing your 11.21 minus your 3.25. That would leave you with 7.96 as your interquartile range. To just give another example then, if we now have this table here, which is number of sales, and then the frequency, so you've got your 1 to 200, 201 to 400, and so forth, we can see, like here, this is going to be discontinuous, there's a gap between the numbers here, then we have these frequencies. Draw a histogram and use interpolation to estimate the median and interquartile range. So here we're going to have to start maybe by adding our third column for the frequency density, and then we'll have to work out what the boundaries here are going to be. Because you can go below 1, we'll go to 0.5, and this will be 200.5, here 200.5, and 400.5, 400.5, and 700.5, here 700.5, and 1,000.5, 1,000.5, and 1,500.5. If here we then were to do the 166 divided by 200, that gets you 0.83. 100 divided by a difference of 200, which is 0.5. 59 divided by a difference of 300, we'll have to round that one, let's say 0.197. 30 divided by 300 is going to be 0.1, and 5 divided by 500, 0.01. Now that you have these, you can start to put them onto your axes. These, I now realise, I do apologise, should be in 0 points for all of them. So 0.4, 0.2, 0.4, 0.6, 0.8, and then 1.0. Then plotting on these bars. So between 0.5 and 200.5, obviously on this axis, this is going to be very tight, so we can only try to approximate as best we can. We're basically on the 0 here. And then we'll be going up to just practically 200. We're going to be going up to 0.83. So that's going to be somewhere about here, and just above the 200 mark. It's going to look something like that. Again, on your actual axes on printed paper, you could be a lot more precise. Here, between 200.5 and 400.5, we're going to go up to 0.5. So that's going to go up to here. Between 400.5 and 700.5, we'll go up to 0.1927. So that's going to be up to here and just below the 0.2. For 700.5 to 1000.5, we're going to go up to 0.1. So that's going to be here, here. And then lastly, for the final 500, you're just going to go to 0.01. So it's basically not going to have any height at all. Okay. So that is the shape that your histogram should take in this case. Now that we have it, we can go about doing the interpolation. So for the median, if we were to add up all of these first, you get a total of 360. If after the median we want half of that, that'll be 180. So going through the frequencies, 166, we haven't reached 180 yet, but we will in the second row. So we're looking here, the lower boundary of which is your 200.5, and add on to that. If you're currently at 166 and you're trying to get to 180, that means you're going to go 14 more into the group out of a total of 100, and then that's going to get times by the class width here of 200. This leaves you with a median of 228.5. As for the quartiles, so if half is 180, then a quarter is going to be 90. 90 is going to lie in that first row, so our lower boundary is going to be the 0.5, and it's just going to be, we're going 90 into the group because we're starting from 0 out of 166, times by the class width of 200. This is going to give you a lower quartile, let's say to 2 decimal places, of 108.93. Then as for the upper quartile, 3/4 of 360 is going to be 270. So going through the frequencies once more, got 166, then add that to the second row, you get 266. So the 270th is going to lie in the next row in this class width, where the lower boundary is 400.5. And you'll add to that. If you're currently at 266, you'll need 4 more to get to 270 out of this next group of 59. And then that's going to be times by that class width of 300. Once again, we'll have to 300. Once again, we're going to have to round. So for this, we're going to get 420.84, the upper quartile. Therefore, for the interquartile range, we'll just minus this number from this number, and that leaves you with 311.91. Okay, if we're happy with that, we can see how we've used our table to construct our histogram to represent the data to show the frequency as area. Let's just see how you could get along with an example of your own. So you have this histogram here where we don't have a scale for the frequency density, but we do for what this axis has now been labelled as time, and we currently have 2 bars that have been drawn on. As part of this, we then also have a partially completed table. We have now different ranges of times and all bar 1 of the frequencies. From this, we want you to complete the table and histogram, and then from that estimate the probability that someone had a time of under 10 seconds. Okay. So have a think about what you can do to try to find the missing information. Pause the video, have a go for yourself, and then press play again when you're ready to compare. Okay, well first of all, we're going to need to scale this frequency density. The only bar, or the only group that we have all the information for, is this second one here, because we have the class width, we have the frequency, and we have the bar that relates to it. So, if we can work out the frequency density from this row, we can then say that that is the height of the bar here, and therefore work out the rest of the scale retroactively. We can't do it for the other bar that we currently have drawn because we're missing its frequency, and you can't do it for any of the other rows because while you can get their frequency density, you don't know how high they would be on that graph. So here, to start off with, in order to try to get our frequency densities, we're going to need the actual boundaries of these class widths. So we're going to have 0.5 and 4.5, 4.5 and 8.5, 8.5 and 10.5, 10.5, 15.5, and 15.5 to 20.5. So just add this other column here then for your frequency density. 2 divided by a difference of 4 is going to be 0.5. 12 divided by a difference of 4 is going to be 3. 8 divided by a difference of 2 is going to be this 4. We don't know about this fourth row here. And then the last one, 3 divided by a difference of 5 is going to be 0.6. So just returning to this bar that we had here. So if we now know that this is a height of 3, we can say that this here is 3. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 up. Okay? So from that, we could say that every 5 is going to be 1. So 1, 2, 3, 4, 5, that's 1. 1, 2, 3, 4, 5, 2, and just double check. 1, 2, 3, 4, 5. Yep, actually we can go up further. 1, 2, 3, 4, 5. We're now at 4 at the top. With this, we can now start filling in some of the other bars. So between the 0.5 and the 4.5, we're going to go up to 0.5 here. So from here to here, 0.5. In this case, that's going to be like 2.5 bars up. So here to here. Already have the second one. Third here, between the 8.5 and the 10.5, we already have those boundaries. We're going to go up to 4. So that will rise up here to 4, and that will rise up here. This bar we can now actually finish off, because we can see that this comes in line with what we've labelled as our 2. So the frequency density is 2. To reverse or to rearrange that equation to get the frequency would be timesing frequency density by class width. The class width here is 5. 5 times 2 gives us a frequency of 10. And lastly here, between the 15.5 up until the 20.5, we need to have a frequency of 0.6. That's going to be 3 of these up, and that is going to go along to just beyond the 20 here. That is what your histogram would look like. Then, just to estimate the probability that someone had a time of under 10 seconds, if we find the 10, it's going to be here, and we're going to be under 10, so we're going to be on the left of this. So that's going to be all of this frequency here, all of this frequency here, and this left-hand side of that dotted line. We know that these two areas together are going to be the 2 and the 12, so that's going to give us 14 so far. But then we'll add to that, so the area of that rectangle here, the height is 4, and for here we're going from 8.5 to 10, so the difference there is 1.5. So 4 times 1.5 will give us 6. Therefore, 2 and 12 and 6, that gives you a number of people as 20. We're not just after the number of people though, we're after the probability, so we need to add these up first. That is a total of 35, so it's 20 over 35, which you're not obliged to simplify, the question hasn't asked that, but if you were going to, you could divide by a factor of 5 and get that that is a 4 out of 7 chance. Okay. From that, let's just look at one other example of how we can again twist this idea of the histograms. So here the variable y was measured to the nearest whole number. 40 observations are given in the table below. So if y is between 10 and 19, there was 13 instances of that. 7 of being between 20 and 24, 15 of being between 25 and 28, and 5 of being between 29 and 30. The histogram was drawn, and the bar representing the 10 to 19 class has a width of 2.5 centimeters and a height of 2.6 centimeters. And from this, we want to find, therefore, what the diagram widths and heights of some of the other bars are going to be. So what we need to do is we need to work out what, just from the table, the width and height would have been. So here, strictly speaking, this will have been from 9.5 to 19.5. Therefore, for our 10 to 19 selection, your class width is going to equal 10, and your frequency density would equal the 13 divided by that 10, which would be 1.3. So we're going from what should have been a 1.3 against 10 to, in fact, a 2.5 and a 2.6. We, from this, can work out what scale factors have been used for each. It's not going to be the same scale factor, they're going to have changed at different proportions, so we need to do them one at a time. For the width, this has been times by a quarter, or divided by 4. Whereas for the heights, for the frequency density, that has been times by 2 to get what it looks like on the actual diagram. Therefore, if we start looking at these other rows here, so for the 20 to 24, this is strictly speaking 19.5 to 24.5. So for that one, your class width should actually be 5, and your frequency density would be the 7 divided by 5, which is going to be 1.4. To get for the actual dimensions of the bar that's drawn, however, this 5 is for the class width, which is your width. That's going to be put over a quarter, or times by a quarter. So that's going to become 5 over 4, or if you prefer 1.25 centimeters. And then this height here is going to be times by 2. So that's going to become 2.8 centimeters. As for this other one here, this would be the 24.5 up until 28.5. So for the 25 to 28 width, your class width is going to be 4, and therefore your frequency density is your 15 divided by the 4, which is going to give you 3.75. To convert these into the bar that's actually representing them, class width, the width at the bottom, is times by a quarter, so it's just 4 over 4, which is going to be 1 centimeter, and the frequency density, the height, gets doubled, so that's going to become 7.5 centimeters. This is just one other way that they can ask you about histograms without having the whole diagram. They'll just instead tell you what would the dimensions of the diagram be, what would the dimensions of one given bar be, therefore find the scale factors and apply those scale factors to some other bars to say what they would look like if you were to draw it out to that scale.